All right, let's go ahead and take care of our spine stretching issue. Now, what I'm referring to is when I move this controller out, you can see that while the curve stretches and obviously the arms and the head come along, the joints don't actually stretch out far enough to meet the original joint up at the top. So it just looks a little bit strange. Now, we could, of course, treat this the way we treat the feet, where if we actually pull the controller out too far, the foot does stay behind, but we're creating a different type of rig for the spine. So we do want those joints to stretch to match. Now, to do that's relatively easy. It just requires a little bit of scripting. So the first little bit we need to do is we're going to type out a tiny script that's going to allow us to know how long this curve is. And by that curve, I'm referring to the actual spine curve inside here. We want to know how long it is because we can use that information to know when the curve is stretched and therefore to know when we need to scale our joints. Now, to get that information, we need to go ahead and use our mel command line right over here. And we're just going to type out a very simple line of code. We're going to type in arc, A-R-C-L-E-N, so arc lane. That's the channel that stores how long the curve is. We'll then type -ch and 1 in order to enable the channel. 0 is off, 1 is on. And you do need to have the actual curve selected when you do this. I'll go ahead and hit enter, and you'll see it'll say result is curve info 1. That's the node that has the information that we need, and it's attached to our curve. I'll go ahead and bring this back down. It just gives us a little bit more real estate to work. There we go. So with this curve selected now, if I hit Control A and go all the way to the end here, you'll see I have curve info 1, and it tells me how long the curve is. The arc length is 3.927. That's the length of the curve if it was laid out completely flat. If I go ahead and stretch it, however, let's say like that, you can see, let me jump back over to it here, that it's automatically adjusted its length. Now it's 6.574. So we can use this information to help us scale out our joints. Let's go ahead and put this back. Now, in order to make use of that information, we can use some very simple scripts. We're going to write some expressions. So to do this, we're going to go over here to Windows, Animation, and we'll choose the expression editor. Now, I have my expression editor set to default to by expression name. The default normally is by object attribute name. I suggest you change to by expression name, especially if you're new to scripting. What this is going to do is it's not going to change or erase your script when you select different objects. When you're in object attribute name mode, it will switch depending on what object you have selected. So we're going to go ahead and type out an expression name up here. We'll call this CYC underscore EXPS for expressions underscore O1. So this is where we'll store all of the expressions for our Cyclops rig. So to write out the first bit of our expression, I'm just holding Control and dragging my middle mouse wheel in order to increase the size of my text here. For the first part of my script, I need to declare a variable. A variable is going to be a container that's going to hold information for me. And the information I need it to hold is the length of that curve. So to declare a variable, I just need to type in a $sign and then anything I want to call it. I'm going to just call it arc lane. So I know that that's the length of my curve. And we'll say that this is going to be equal to that length information, which we can find by selecting, again, our curve. I'll hit Control A and we'll go all the way to the end here. It says curve info 1 node. In fact, I can even just copy the name. We'll copy the name and we'll say that this will be equal to curve info 1. Now, what part of curve info 1? The arc length. So that'll be ARC, capital L, length. There we go. I'll go ahead and add a semicolon to show that this line of code is finished. And then I can just hit create. I didn't get any errors and my expression's been created. All I've really done so far, though, is just take this information and stored it in this $arc lane. Now, I want to go ahead and use this information to scale out my joints. So let's go ahead and start by selecting this joint here, and we'll just take its name. Now, the way I designed out the spine is that the X is the channel I want to scale. That's the one that's going to point up towards the next joint. So what I'm going to do is over here on my next line, I'm going to paste in the name of my joint, type in dot scale X, and then we'll tell it that it's going to be equal to $arc lane. So basically the value of that curve. Now, because this updates in real time, every time the curve gets longer, This number gets larger, and therefore the scale will get larger. However, we're going to have a slight problem. Let me hit edit and show you what I mean. If you take a look over here, the problem now is the spine is shot up through his head. The reason is that it's used the length of the curve, which is 3.927 right there. We don't want that. We want the default length to be 1. We only want it to get longer when the spine gets longer. So what we can do is use a simple bit of math. What I'm going to do is divide the arc length by itself. Any number divided by itself is 1. So I'll put in a division sign, and let's type in that number. The number was 3.927. That's the default length of our curve. 3.927. I'll go ahead and hit edit right here, and you could see that the spine is snapped back. And now when I move this, you could see that bottom joint is actually stretching. So we want to go ahead and do that to all the joints that are part of our spine. And the cool part about using scripting is we can just do that with some simple copy and paste. So I'm going to go ahead and grab this line here. We'll copy that and we'll paste it in 3 more times for joint 2 of the spine, joint 3, and joint 4. And let's go ahead and hit edit. There we go, and we can close that off. And now you could see those joints are going to scale to match regardless of where this goes. All right, so now let's go ahead and reattach this geometry so that we can see it move with it. Now, the reason I had removed it is that whenever we have joints that are going to scale, and if we have something that's parent constrained to those joints, if our pivot isn't directly on that joint, we're going to get very strange transforms. These different parts of the spine are going to like shoot through his back. We don't want that. So we need to go in now and change the pivot of each one of these pieces to match the joint, and then we can reconstrain them. So I'm just going to hit insert to go into pivot mode, and we'll just go ahead and snap that into place. Again, I want that directly on the joint. Right there. There we go. We'll do the same with this piece of geometry here. Let's go ahead and hit modify center pivot to bring it a little bit closer. And now I'll go ahead and snap that. We'll do the same with this one. There's just 4 of them. There we go. We'll again go to modify center pivot to bring it back up here. Let's snap that into place right there. Okay, and then the last one is this one up here. Oops, I want to select that piece of geometry. There we go. Modify center pivot. Again, I'll hit insert, and let's go ahead and again snap that into place right there. Okay, now I can go ahead and reparent constrain all of these. So the driver will once again be this joint here. The driven will be this piece of geometry. Constrain parent. We'll do the same here. Oops, let me grab that. Parent. Let's do this one up here. Driver driven. Constrain parent. There we go. And now the last one. Let's grab the joint there. Driven, constrain parent. Now you could see that everything works just fine. See? All of that's working great, and we can even have him sit down here, and all that's coming along for the ride now. All right, so we've taken care of the stretching. Now, there still are a few other issues we need to take care of before we're done with our spine. So in the next clip, let's take a look at how we can add a little bit of twisting to his spine, because right now, when we rotate here, you can see his spine doesn't actually twist. It stays facing forward. So we want to address that. So again, we'll do that in our next clip.